Hello there, welcome to the learning of engineering tutorials. In this video lectures, we are trying to learn the strain energy stored in a hollow shaft due to the torsional loads. As we know, the strain energy is due to the stretching of the object whenever it is applying the load, that is external load. As we know, in this case, the torsional loads is going to be coming. It means that the shaft is going to be made to rotate about its own axis. The loading system is going to be here. The two equal and opposite loads are going to be acting on that system. That's why we can make to rotate the object in its own axis. In this process, what happened? Each and every particle of this shaft is going to be subjected to the torsional forces. Now, due to this torsional force and how much energy it is stored, that energy is used to come back its original position. It means it will regain its original shape of the object. So in this case, what will happen, that is going to be, here is indicating that is your inner radius of the shaft, outer radius of the shaft. I have taken the thickness of this member as well as that is the radius, that is location of the elemental strip, and the thickness is going to be existed here. So I'm not going to be deriving completely here, and with the help of the previous video lectures, I have taken I borrowed from there and I started here. So the strain energy stored in a shaft, suppose we are going to be taking, that is the strain energy is equal to, that's going to be the T square, tau square into L by 2C R naught square into J. The R naught is nothing but here, that is going to be your outer radius of the shaft, and J is nothing but the polar moment of inertia. With this help, I am going to be taking here, that's the J is equal to 5 by 32 and d to the power of 4 minus small d to the power of 4. Capital D is going to be your outer diameter and small d is going to be called your inner diameter. So then I am going to be substituting in this equation and I am going to be simplifying also. So then tau square L by 2C R naught square pi by 32, that, and I am going to be rewriting this equation d square capital D square plus small d square into capital D square minus small d square. So then in this case, I am going to be simplifying further. In this case, that R naught I am going to be substituting here is going to be d by 2. So that is the outer diameter by 2. So then what happened, this is going to be the 4 times, it will going to be cancelled into 8 times. Then I am going to be rewriting 8 into 2 16, that I am going to be writing the same equation, the tau square by 4C d square 5 by 4 capital D square minus small d square into L into d square plus small d square we have taken. So this is going to be representing the volume of the hollow shaft. So the same equation, this is the equation, this you can use for the solid shaft as well as the hollow shaft, and this equation I am going to be using here for the derivation of the hollow shaft. So what is the final magnitude? Tau square by 4C capital D square in bracket capital D square plus small d square into volume of the object. So this way we are going to be calculating the magnitude of the strain energy stored in a hollow shaft. I hope you are able to understand here how to take the elemental strip and how to convert the strain energy existed in the solid shaft into the hollow shaft, and this is the final magnitude, the way we are going to be calculating. This mathematical model helpful to find out the magnitude of that. So I hope you are able to understand. Still you feel any confusions, please put in the comment section so that I can reach you out. So thank you.